Okay, this is calculus, section 4.5, curve sketching. Um, we have graphing calculators, and they can graph a lot of things, but it's important to understand what happens in a curve. So that's really what this section is about. However, I allow you to do the odds, and I allow you to use your calculators. So basically, it's just kind of a formality, but I want you to look at things that we're going to look at. And the first thing is, we've talked about vertical asymptotes, correct? And it's always important to identify the vertical asymptotes. So let's start with that. In a graph, oftentimes there are vertical asymptotes. And how do we find them? They are found by setting the denominator equal to 0 and solving for x. So whatever's in the denominator, you find it. If there is no denominator, is there a vertical asymptote? The answer is no.
Okay.
If there's no denominator, there's no vertical asymptote. Okay? Now, a graph can, and I don't say this very often, never cross a vertical asymptote. Okay? It can cross a horizontal one, but it can never cross vertical. All right? Any questions thus far? So we've pretty much established that the vertical asymptote. Do you have a question?
Well, why? That was the big one, but I figured you would get to it eventually.
Because why can't it cross it? Because
It's not.
the denominator is 0, making it undefined at that particular x value. Therefore, it can never have that value. It goes up to infinity or down to negative infinity.
So what is it exactly that's not crossing?
The graph, whatever your graph is.
Okay.
Remember, your graph follows asymptotes.
Mhm.
Okay, this graph, this picture on the whatever, it will not cross it. It'll follow it. So
Okay.
if I have a just an example is if I have a, by the way, asymptotes are dotted, right?
Mhm.
If I have this, the graph will always follow it, but it will never cross it.
Oh, I got it.
Okay. Sometimes a horizontal asymptote, a graph may cross it and then come back and follow it. You see what I'm saying? That happens from time to time, but it will never cross a vertical, and it's because the denominator is 0. Okay? All right. So the next thing we're going to talk about is horizontal asymptotes. As I just said, graphs can cross it. It's not doesn't happen very often, but it does happen. So I can't say that it never crosses. So we're going to look at some different kinds of horizontal asymptotes, and I'm going to give you some quick cheater points. Okay, let's let n be the degree of the variable, the highest degree. Oh, I should say the highest degree of the variable in the numerator. Okay, so it's an x squared or whatever, an x cubed. It's the highest degree. You understand that? So if you've got more than one degrees or exponents in the numerator, you find the highest one. Okay, and let's let m be the highest degree of the variable in the denominator. Okay? All right? I'm defining that. Okay, I'm going to give you some rules. The first one is if the highest degree in the numerator is smaller than the highest degree in the denominator. So maybe you have like an x over x squared, where the degree is 1 and this is 2. Got it? If this is the case, the x-axis
is a horizontal asymptote.
So
Okay.
would the x-axis be a horizontal asymptote if that was like, if the x squared was like an x to the fourth power or
No.
something? Or is it only x squared?
Well, yes, I'm sorry, yes. If this degree is less than this
Okay.
degree, I'm sorry, I got my M and N switched around. Okay? Now, what happens if n is equal to n? Okay, in other words, you know, we had x squared over x squared, okay?
I'm gonna show you one.
The line y equals a over b is a horizontal asymptote. Now, I gotta tell you what a and b are, right? But I'm gonna have you write that down. A is the leading coefficient of the x with highest degree. Right? Well, you know what leading coefficient is, right? Okay, so let's not do that. That's a lot of words. The leading coefficient of the numerator, right? And b is the leading coefficient of the denominator. So you just take the leading coefficient of the numerator over the leading coefficient of the denominator, and what you have is the asymptote. Y equals that. So this is a horizontal line. Do you understand it? It's a horizontal line because it's y equals. Okay? And then the last one, obviously n is greater than m, right? No horizontal asymptote. And I'm gonna run out of room because there's one more, there's a solution here. Maybe I can write it there. I am under here, all right? And I'm telling you that n equals m plus 1. So you can see that n is smaller than m. Excuse me. Yes, n is greater than m by 1. So it would be like this case, x to the third over x squared, okay? What we have is a possibility of a slant asymptote. A slant asymptote is a line, is a slanted line, and it usually has a hole in it somewhere, where the denominator is 0. Okay, all right, and I will give you an example of that. Why don't we do that now, and then I'll come back to graphing it, okay? Sometimes it has a slant asymptote. Sometimes a graph has a slant asymptote that has a hole in it. Sometimes they don't. All right, it depends on the situation. Okay? Let's take a look at. Why don't we just graph this one? Just show you one with a slant asymptote, because it's kind of the odd form. Do you guys have graph paper?
Yeah.
Okay, I think Sophia and Izzy have it too. Okay. All right, so we're looking at this, and we're talking about asymptotes. And I'm gonna kind of graph, I've kind of showed you how to find the asymptote, so we can do curve sketching. We can do, you can do all those things. We can do concave up and concave down now, okay? But I'm not really pushing for those things. But I'm telling you that the reason why this is in this particular section is we've talked about graphs and what they do in terms of the critical points, maximum, min points, right? We can do all that, all right? Let's take a look now
at this one. Okay, if we look at it, if we set the denominator to equal to 0, okay, we have x squared plus 1 equals 0, correct? All right, it does have a denominator, but when you set it equal to 0, you get x squared equals a -1. That is not a rational number, is it? That's not a, excuse me, that's not a real number, that's an imaginary number, right? So right now, we don't have any vertical asymptotes. So not everything has a denominator, you know, not everything that has a denominator produces a vertical asymptote, okay? All right, but you'll notice that this is greater than this by 1, so we're right here. N is greater than m, and it's greater by 1, okay? So the way we do it, there are different ways to do it. One is to do it long division, okay? Do you remember long division? No. Yeah, you didn't like it, did you? Okay, here's another one. You remember that technique that we divide by the highest power in the denominator and take the limitation of it? We can do that. So we can take the limitation as x approaches infinity of x to the third divided by x squared over x squared over x squared plus 1 over x squared. All I'm doing is I'm dividing by the greatest. Remember we did that when we took the limitation, if we were trying to find the limitation?
Yeah.
Okay, so what happens is we get the limitation as x approaches infinity of x over 1 plus 1 over x squared, correct? You remember that?
Yes.
Now, as x approaches infinity, what does this do?
Goes to 0.
It goes to 0. So what we end up getting is x over 1 or x, right? So what we have is y equals x is our slant asymptote, okay? All right, so let's go ahead and graph that. So y equals x is, it goes through 0, 0, has a slope of 1, so it looks like this. All right, like that. What's going to happen is this graph is going to somehow wrap itself around. Okay, now we can find the maximum and minimum points by taking the derivative. However, taking the derivative, this would be very difficult, wouldn't it? Now the book says do it. All right, and we would divide and we'd find the derivative and we'd set it equal to 0, but we have 1 over x. By the time you do that, you could just set up a t-table. So my suggestion is set up a t-table. Okay? All right, so I set up a t-table, I stay around the origin, all right? So I'm going to go from a -3, and I'm going to put a -3, okay? So if I put a -3 in here, in the numerator, what do I get? -27 over 10, which is a -2.7. Is that correct? All right. -2, I get a -8 over 4 plus 1 is 5, which
Yep.
is, what is that? Negative, just a decimal. 1.6.
-1.6.
Okay. And so a negative 1, I get a -1 over 2, which we know is -0.5. 0, we get 0, right?
Yep.
So that's where it touches the y-axis and the x-axis, right? So there's an intercept, okay? Let's put in a negative, or let's put in 1. I get 1 over 2, so I get a positive 1/2, right?
Yep.
And I put 2 in, I get 8 over 5.
So it's 1.6.
So are you checking this out? I bet this is 2.7, right? Okay, I'm just gonna throw in a 4 because that will give us a -2, won't it? 4 is 64 over 16 plus 1 is 17. Would you do that as a decimal?
64 divided by 17,
Yeah.
3.76.
It's what?
3.8.
Yeah, 3.8. All right, so let's look at this. And we have the -3.8, right? So we go through 0, 0, right? We go from 1 is 0.5, so 1 is 0.5, so it's right underneath it. And then at 2, it's 1.6, so at 2 it's 1.6. And at 3 it's what?
2.7.
2.7. Okay? and at, 4 is 3.8, right? Look at that, it's getting closer and closer to that line, right?
Yeah.
But watch what happens, if you go on this side, and my line is off, I can tell my asymptote line is off, okay? I'm gonna kind of freehand it, but your asymptote line goes through these, right?
Yeah.
So what happens is, and you can check me on this, but it goes like this. It comes at -1, it's 1/2, right? So it goes like this, and then it crosses at the origin and it gets closer like this. See that? So it actually crosses the slant asymptote and follows that.
So that where it crosses is the hole in the asymptote then?
There is no hole
Oh.
in the asymptote. It just crosses it and then it follows it.
Okay.
Okay, the asymptote doesn't have a hole in it. The slant asymptote sometimes in a line will have a hole at an x value that makes it the denominator 0, like that.
Oh, okay.
Yeah, so there's no hole in asymptote, there's a hole in the graph.
Oh, okay.
Okay, so what are we looking for? What are important? What are important? Well, the asymptotes are definitely important, correct? The maximum and minimum points are important, and we can find those, okay? But we can also use x and y values. What else is important? X and y intercepts are important. Those are all important facts on the graph. All right, so we're going to do the odds. We want to look at the domain. Let's take a look at number 1. It says, use the guidelines of this section to sketch a curve. I would like a fairly good sketch. So let's do number 3. It looks a little bit more complicated. All right. So 3 equals y equals 2 minus 15x plus 9x squared minus x cubed. Okay, we're going to take a look at this one. And we may do some different things on this one because it's a little bit more complicated, right? Doesn't have any vertical asymptotes. The highest value is -3. We don't have a denominator, do we? So we're probably looking at no asymptotes. So we got to find some other things about it. If we put 0 in for x, right? We can catch y at what? 2. So we do know that it has a y-intercept of 2. So you can put that on there right away, right? Goes through that point right there. Okay, now, this one does not have a numerator, or it does not have a denominator, so we're limited on asymptotes. We can't find where, so what we want to do is we want to try to find some critical points. How do we find critical points? We take the derivative, correct?
Yes.
So we have, I'm going to flip this around. Let's flip it around. Negative x to the third plus 9x squared minus 15x plus 2. Is that right? So y prime equals negative 3x squared plus 18x minus 15, correct?
Yep.
All right. All right, what do we do with this to find critical points?
Set it equal to
Set it equal to 0. So 0 equals a negative 3x squared plus 18x minus 15. Now, I do not like a negative x squared. So not only I'm going to divide by negative, but I'm going to divide, since I got it equal 0, I can do whatever I want. I'm going to divide by -3. So I get 0 equals x squared plus a negative 6x plus 5. Okay, now we're talking, right? Because I can factor that, and I can go, this is x minus 2. Nope.
No, x minus
That's
5,
5.
x minus 1.
Thank you. So my critical points are 5 something and 1 something. All right, how do I find then what's the something?
Put it back in the original.
All right, I'm putting back in the original. All right, and we need to find out whether they're a max or a min, right? All right, let's go ahead. Would you put the 5 back in using your calculator? Or would you put the 1 back in using your calculator? Brian got the hard one. You got 527?
27.
What's 1?
-5.
-5, okay. Alright, so we know those are critical points. Let's do a double derivative and check whether they hold water or don't hold water, shall we?
Yep.
Alright, so let's do a double derivative, which is right here. This, we can take a derivative of this, no, we have to take it this. I'm sorry, so let's go back up here, just to be safe. A -6x plus 18, is that correct? Right?
Yeah.
Okay, now, I believe we put 5 in there and see if it's positive or negative. So we're gonna do f double prime of 5. Let's see what happens. So a -30, that's negative, isn't it? Yeah. And what is f double prime of 1? What's it? Positive. Okay, so if it's negative,
It doesn't hold water, so it is a,
Conjugate.
it's a
Oh.
max, right? We're gonna guess that this is a max and this is a min, right? Holds water, positive. All right? Now, we should probably set that double derivative equal to 0 to find what?
points of inflection.
Points of inflection. So we factor out -6, we get x minus 3. I'm thinking 3, right? All right, so let's take a look at 3 now. 3, let's put 3 in. Would you both put 3 in just to double check it? Hopefully it's between a -5 and 27.
I got
Yeah, you got 11? Okay, now, we could put that 3 and use the first derivative test, and we could find out if it was going from negative to negative or positive to positive, but we're just gonna hang loose now, because Mr. Ellis lets you cheat a little bit here. Now, what I want you to do is I want you to go ahead and plug this into your calculator. This is the part we get to cheat at, and you can do it on the test too.
Okay.
I'm not proud. Well, we have these devices, right?
Let's-
Okay, you got it? Okay, can I ask you a question?
Yeah.
At 1, does it look like we have a -5?
Yes.
Okay, and that is a minimum, is that right?
Yes.
So I'm assuming that it comes down like this?
It's
On the
Okay.
other side.
positive. It's a positive
-1, I got, oh, it's 1 and -5, I'm sorry. It's over here, like that. Is that right? I'm sorry, I'm looking at it slant. Now, so it comes down and swoops up?
Here.
Okay. It doesn't have any max or min on the left side, right? 311 is the next one, right? So 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's a critical point. So does it come from up here and come down?
Yep.
Okay,
Down.
so it comes down here, like this, it hits this,
Yep.
and it goes back up to that point right there. And at that point, does it do this, kind of?
Ish. Only
Can you zoom in on it?
the window bigger.
Make the window bigger? And then it goes up crazy, right? Like this, and at 527 up there, it's gonna come back down, right?
Yeah.
So it's gonna come off my graph at 527, so goodness, 527, it's gonna go up, way up there, and then it's gonna come back down, and then does it just,
Yeah, just drops.
okay. But where does it touch? the x-axis. We would have to put this equal to 0 and factor it, right? But I'm not concerned about it. You look on your graph and tell me approximately where it touches the x-axis. In between what two numbers?
1 and 2, or sorry, 0 and 1.
Yep.
2 and 3.
Yep.
And it looks
Oh,
like,
2 and 3?
yeah,
Okay.
It looks like, 6 and 7.
2 and 3, so it's like this, right?
Yeah.
yep.
And then 6 and 7. 1, 2, 3, 4, 5, 6 between these two, so I'm way off. So, you see what I'm doing?
Yeah.
I'm getting an estimate of what to do. Now, I don't show the maximum point up there, but there is a maximum point where it comes back down. Well, and a local maximum point, okay? So that's what I want you to do. I want you to find out as much as we've talked about in this chapter, with vertical asymptotes, all that. This one didn't have any. I want you to use your critical points if possible, and then I want you to graph it to kind of sketch it, okay? Now it's a sketch. Doesn't have to be wonderful, okay? You're doing the odds, so you have all the answers, but you also have your graphing. I just want you to get a feel for it. Okay, so what page is that?
248.
248. Numbers 1 through 25 off. Okay? I don't want you to spend a lot of time on it. You have today and tomorrow to work on it, you know, and I just want you to get a feel for it. Actually, let's do 1 through 19 on. Okay? 1 through 19 on. So is that on the, would you tell them, would one of you guys text them? 1 through 19. All right, thank you guys. All right. If they don't watch it, I think they might. Will you stop it, please?